All right, class, section 3.2, use parallel lines and transversals. We're going to be able to find angle measures formed by parallel lines cut by a transversal. So corresponding angles postulate states if lines are parallel, then corresponding angles are congruent. If I were to number my angles, then I know if these two lines are parallel, then all of my corresponding angles are going to be congruent. So that would be angles 1 and 5. Angle 1 would be congruent with angle 5. Angle 2 and 6 would be congruent. Angle 2 congruent to angle 6. Angle 3 and angle 7 would be congruent. And angles 4 and 8 would be congruent. That's your corresponding angles postulate. The lines have to be parallel for those to be congruent. Must be parallel. Same with alternate interior angles theorem. If our two lines are parallel, then alternate interior angles are congruent. So number our angles real quick. Our alternate interior, so inside the two lines on opposite ends of the transversals. That'd be angles 3 and 6 would be congruent. And you can see, even looking at that picture, they're both acute angles, both 3 and 6. If I were to look at angles 4 and 5, I can see that those are obtuse. So I would know not to match those up with angle 3 or angle 6. But angles 5 and angle 4 would also be alternate interior. And they would be congruent. You can see in the picture, 4 and 5 look like they would be obtuse. 3 and 6 look like they're acute. That should also be an indication for matching up proper alternate interior angles. Then alternate exterior angles theorem. If the lines are parallel, then alternate exterior angles are congruent. So our alternate opposite sides of the transversal, exterior on the outside of the parallel lines. So angles 1 and 8 would be congruent. And angles 2 and 7 would be congruent. That's the alternate exterior angles theorem. And again, the lines have to be parallel for those to be congruent. Otherwise, they're just alternate exterior angles. It doesn't mean that they would have to be congruent. But if they're parallel, then they are. Then consecutive interior angles theorem. If our lines are parallel, then consecutive angles, consecutive interior angles, are supplementary. So not congruent, supplementary. And remember, supplementary means adds together to get 180. So I'm going to number my angles real quick. Our consecutive interior angles would be 3 and 5. And we're saying that those are supplementary. So 3 and 5 would be added together. Let's write that better. Measure of angle 3 plus the measure of angle 5 equals 180. Also, we would have 4 and 6. Measure of angle 4 plus the measure of angle 6 equals 180. And actually, if you're looking at the filled-in notes, I have 3 and 4 switched around in their place. So in the filled-in notes, it says measure of angle 4 plus 5 is 180, and 3 plus 6 is 180. So look carefully at where they're placed. You can see those 2 red angles would be the supplementary ones. The 2 green angles would be the supplementary ones. So don't just focus on what those numbers are. Identify congruent angles. So the measure of 3 of the numbered angles is 125 degrees. We need to identify the angles and explain our reasoning. So the measure of 3 of the numbered angles is 125 degrees. So we see this one is 125. We need to find 3 other numbers that also are going to be 125 and the reason for it. So I could say angle 1. Angle 1 is 125 degrees because it's a vertical angle with 125. So that's a vertical angles, remember those. Angle 1 would be equal to that. We can see that these 2 lines are parallel. So a corresponding angle would also be congruent. It would be equal to 125. And our corresponding angle is 7. So angle 7 is corresponding in the same position on the line, same side of the transversal. So corresponding angles, and then we also have our alternate interior angles. You can see that 125 would be an interior angle. So I look at my alternate interior angle, which would be angle 5. Angles 5 and 125 are alternate interior angles. Next, if the measure of angle 7 equals 75 degrees, we need to find the measure of angle 1, 3, and 5, and tell which postulate or theorem we use in each case. So we're told that angle 7 is 75 degrees. We need to find 1, 3, and 5. So let's look at angle 1 and look at its relationship to angle 7. they would be alternate exterior angles with one another. Outside the parallel lines, opposite sides of the transversal. So the measure of angle 1, and we know if those lines are parallel, alternate exterior angles are congruent. So measure of angle 1 would equal 75 degrees because alternate exterior angles, and then we see angle 3 is right there, and its relationship to angle 7 would be corresponding. It's in the same position on the parallel line, same side of the transversal. So 3 and 7 are corresponding angles, and that would also be 75 degrees. Because corresponding angles in parallel lines are congruent. So the corresponding angles postulate for theorem. I guess it's the postulate. Okay. And then angle 5, its relationship to angle 7, that would be vertical. And vertical angles are congruent. So the measure of angle 5 is 75 degrees. Because of the vertical angles congruence theorem. Vertical angles. Next, we need to find the value of x. So let's look at our two angles. What is their relationship? They're outside the parallel lines and on opposite ends of the transversal. So they are exterior and alternate. So alternate exterior angles. And alternate exterior angles, when we're dealing with parallel lines, are going to be congruent. So 113 equals 3x minus 4. And then we just need to solve for x. And 17 divided by 3, it's going to give us 39. So x is 39, and that's all we needed to find. Make sure you pay attention. Is it asking for the value of x, or is it asking for the measure of the angle? If we needed to know the measure of the angle, then we need to plug back in. Obviously, it would be 113 because we know that they're congruent. But if it's not as obvious as that, make sure you're paying attention to what the question asks. Are you solving for x, or are you solving for the angle? Here we need to find the value of x again. So let's look at their relationship. Our angle up here is on the outside. It's an exterior angle. But our angle here is on the inside. It's an interior angle. But they're not corresponding. They're not alternate exterior because one of them's on the inside. They're not alternate interior because one of them's on the outside. They're not corresponding because they're not on the same side of the transversal. They're not consecutive interior either. So these don't have a direct relationship. This isn't one of those 4 or even 5, including vertical angles, relationships that we've been talking about. But we do know a few other things. We know that this angle here, let's call it angle y, is a vertical angle to 3x minus 7. So y would equal 3x minus 7. And so we can say that y here is 3x minus 7. So that angle down here now is the same. And now we have consecutive interior angles with y and x plus 5. And our consecutive interior are going to be supplementary. So 3x plus 7 plus x plus 5 equals 180. So that, then I need to simplify, combine my like terms. I get 4x plus 12 equals 180. Subtract 12. It's 168. And 168 divided by 4 gives me 42. So I know x equals 42. Now you may not have gone the route of vertical angles and then consecutive interior angles. Some other ways you could have looked at this is you could have seen that this angle corresponds with that one, so it would be equal to that. So then I would still do the same thing, because now this green angle, if we call it y, would be a linear pair with x plus 5, so it's still supplementary. Or if I know it's a linear pair with this angle here, I know that that would be congruent because it's corresponding with x plus 5. So just using your knowledge of the different angle relationships, you can work around and figure out how to set up to solve for any missing value. Next, we need to use the diagram to solve with this information. We know that the measure of angle 3 is 68 degrees. And 68 degrees there. Measure of angle 8 is 2x plus 4. And we need to find the value of x and show all of our steps. So we know angle 3 and angle 8 is 2x plus 4, and we need to solve for x. So again, we're looking at and seeing if they have a relationship. 3 and 8 are not one of our 5 options. They're not alternate exterior. They are both exterior angles, but they're not alternate exterior. They're not corresponding because they're not in the same position. They're not alternate interior, and they're not consecutive interior because they're not on the inside. And they're also not vertical angles. So they're none of those. So we need to identify, using our knowledge of some of the other angles, find out what they would be, if they would be congruent or if they would be supplementary. Well, just looking at the picture, you should be able to identify angle 3 looks like an acute angle, and angle 8 looks like an obtuse angle. And since we have these parallel lines, they're either going to be congruent or they're going to be supplementary. So if one is acute and one is obtuse, they're clearly not congruent. They would need to be supplementary. Another way is identify that 3 and 4 are a linear pair. They form that line there. So 3 and 4 would be supplementary. And I know 4 and 8 are corresponding angles, so they would be congruent. So that tells me 3 and 8 are supplementary. So they will add up to 180. can simplify. Subtract 72 to both sides. And then divide by 2. So I should get x equals 54. And if I want to plug x in for 2x plus 4, I should end up with a number supplementary to 68, or the supplement of 68, which is 112. Okay, in this image, it doesn't look like those other parallel lines and transversals that we've dealt with things numbered for us and such. But we do see we have two parallel lines. And if we imagine them extending on, we can also see that we have two lines that intersect those parallel lines. So we have two different transversals. We have one here that I'm drawing in blue, and one that's drawn in red. And then using those two different transversals, we can imagine two different sets of numbers 1 through 8 for each of those angles that they form. So we're going to use those to help us figure out what x and y are. So first let's look at angle x. And we want to see, is there any angle shown that we know has a relationship with angle x? So looking at our two green parallel lines, and x is formed by a green parallel line and the blue transversal. So right now we're focused on the blue transversal. Ignore the red line for now while we're looking at x. So looking at x, and along the blue line is 65 degrees. Does it have a relationship with angle x? And the answer is yes. They are corresponding angles. So angle x and angle 65 degrees are corresponding angles. And if they're corresponding angles along parallel lines, then they are congruent. So x equals 65 degrees. Now we need to look at y. So I'm going to erase all this. And we want to look at angle y. Does angle y have a special relationship with any of these other angles? Let me put back up my parallel lines. And a transversal. Well, 55 degrees is the only other angle that goes along the blue transversal, but does it have a special relationship with y? Y is actually not formed by the parallel lines and the blue transversal. It's formed by the two transversals. So you can see y is formed by the blue and the red line, not by the parallel lines. So we actually can't use those special relationships to help us find y. But what we can determine is, if we notice, well, we already know x is 65. Down here is 55. So this, with vertical angles, this one would have to be 55 degrees. And the 65 angle and the 55 angle and y all form along that red line. So they are all added together to be 180. So they're not a linear pair because there's 3 of them, but they're still supplementary all together. They all add up to 180. So we can say 65 plus 55 plus y equals 180. So simplifying, we get 120 plus y equals 180. Subtract 120 on both sides. And we see that y equals 60. So we had to think outside the box a little bit there. Another way you could have done it is knowing with alternate interior angles, this angle would have also been 55. And there you have a triangle, and you know 2 of the interior angles of that triangle. So all 3 would need to add up to be 180. You could solve it that way also. All right, that's it on the notes. Make sure you do your homework.